live sooner or later. And this is me recording, I don't know, designing a shopping cart that I might integrate into another solution for making a request that is reliant on GPS tracking. But hence the Get Right app that I probably spent like 50 hours on YouTube live streaming. And so in this one, I'm not really feeling it right now, but I'm gonna try to code at least 2 hours a day on this kata of building out a shopping cart, and with the hopes that whenever I integrate this, that it'll connect to some back end for some stores and retrieve, product SKUs, product price, product image, and be able to feed that to the user interface. But right now, the purpose of this exercise or this kata is just to go through the workflow of just building a shopping cart. So specifically, I have a shopping cart solution. And it'll create a project. And there's going to be, not sure how I want to do this. Let me just go off of muscle memory. There's a specification, and then that specification can have a shopping cart dot domain, perhaps. But that specification will also have a shopping cart dot specification. And yeah, I guess let me do this. There's a shopping cart folder, and maybe the shopping cart dot domain goes up there, because then there will also be a shopping cart dot gateway, perhaps. Something like shopping cart dot gateway, data gateway. Something like that. Get rid of that. And for this domain, get rid of the photo over here. And so we can throw this specification folder under there. And that kind of looks like how I want to model things in the solution. So in the specification, there's this library that we'll call language. And then we'll add a Control-Shift-A and have a operations. Okay. And operations will come after language. And in the shopping cart specification, which like that should be a capital C. The shopping carts specification library. For operations, this is where I want to flush out the main operations for my shopping cart. So do shopping cart operations. Specification is a come here. Shopping cart dot language over here. And then I can say type, and then what in the shopping, well, hold up, let me go back. I could say something like this. I could say, as a shopper, I want to browse products and have the ability to add/remove items from my cart. If you add to your cart. If you remove them from your cart. And so as a shopper, I want to browse products and check out. Or you could say, as a shopper, I want to add products to my shopping cart. So you could say browse slash add products, or browse and ultimately add products to my shopping cart, something like that. We also want to have the ability to like remove items as well. So as a shopper, I want to have the ability to browse, add, and remove products within my shopping cart. Something like that. Okay. Then I could define some operations that will provide that support, or translate it as some operations that will support that mission or that user story. So I could say type what? Well, this is kind of convoluted because the shopping cart, you only add and remove items. You don't browse items in your shopping cart. All right. So we got to nip that in the bud, that there's no browsing on the shopping cart. So because of that, there's going to be potentially another domain in here called browse store or whatever. When you browse a store, then it's going to have a dependency on maybe a shopping cart interface or something. But there's a difference between browsing, where you're observing items that you can purchase, and then the action is to add items to your cart. So if we look at this, ultimately there's going to have to be a checkout. And so I'll update the mission statement to, as a shopper, I want to have the ability to add and remove items. Say add, boom, slash remove items within my shopping cart and checkout, right? So you have type checkout function equals, you have this shopping cart, and it's going to be your input, and the output is going to be some result type that, if successful, is going to be a transaction, and if it's not successful, it's going to be a error description, okay, of type string, I guess. So then I could potentially say that there's going to be a type called error description. It's going to be of type some generic value. It's going to be a record in which it's going to be a message equals, and then whatever that value is. Can I do it like that? It's been a while since I did this. What am I doing wrong? Type error description operates on some generic type called A. We say it's going to be a record that equals whatever this A is. Oh, yeah, I can't use the equal sign. All right, something like that. And the other one is the, I don't know, so this error description should light up, but it, okay, it's recognized. Okay. So the other one is type transaction equals, and we're just going to say that this transaction is going to be a, it's going to at least have a transaction ID, that's going to be of type, I don't know, transaction ID. Okay. For right now. And so I could then say that my transaction ID is a type equals transaction ID of string. Okay. Now what? You know, sometimes I think that I don't really know what the type of a transaction ID is going to be. It could be an int, it could be a GUID, or it could be a string. String is pretty universal because then I could parse, uh, using a string, I could parse that string and return a GUID. Using that string, I could parse that, or using an int, I could parse that int, or parse that string and return the int. It's like 3:30 in the morning, so I'm kind of tired. So I think a transaction ID should be of just a certain type. Can I do that? Okay. And so I'm not sure if I can do that. Uh, in this case, shoot. In this case, I think it's going to say, do something like that. In this checkout, it's going to potentially be nasty. Okay, it's okay with that right now. This is interesting because usually when I have a error description or anything else, I already know the type that I'm going to be using. But in this case, this stuff is just very generic. And maybe that's okay. I'm not sure yet. Um, so now what? We have the shopping cart that needs to be defined. So I say type shopping cart equals gonna be some record. And it's gonna be what goes in the shopping cart. A shopping cart is something that could be persisted. So why not? Shopping carts ID. And that's going to be of something. And if I do that, then I see that this checkout is, I see all these types that rely on these structures that are generic. I see the function signatures being kind of verbose, but whatever, let's go with it. And I can update it to a string later. I mean, this is an interesting exercise. So shopping cart is shopping cart ID. Boom, like that. So now we can change the hold up, let me go back. Our checkout can operate on now A and B. Your shopping cart will be operating on B, but I can change that shopping cart is operating on A and then transaction is on B. Okay. Now what? All this stuff still builds. And so we've defined, we can take the language that we flushed out for our checkout function that may still be incomplete, I'm not sure yet. And we can migrate those types that we recently defined into our language.fs file. Okay. And bring this up here. And we can go ahead and open language. I can spell language. All right, so now everything builds. Now what? Yeah, I don't like that. Put it back down here. So we have this checkout. It takes the shopping cart. That shopping cart, the ID. Okay. So maybe we change this to cart ID, and B is air, something like that. So then our shopping cart has a cart ID, and our error description operates on air. Oh no. Okay. Now what? Control Shift B, that still builds. This stuff is like hella generic right now. I'm afraid it may be too generic. If I treat every ID as generic, I feel like the more functions that the more function types that I defined are going to be, their signatures are going to be pretty cryptic. But I'm going to go with it for right now. I can always refactor all that stuff later. This is kind of new territory for me of making a very, very infinitely generic function or suite of functions, suite of operations that this domain is going to rely on. So to iterate, for our operations for our shopping cart specification, I have a operation called checkout that, even this is kind of hard to read, right? I'm not sure if I like this. A checkout that's going to operate on a card ID in the air, and that operation called checkout is going to take as input the shopping cart, and it's going to output, if successful, a transaction that's going to focus on a card ID. And yeah, I don't like this. I think I'm better off not having a generic ID type for a transaction, not having a generic ID type for a cart. But the specification is like you can just plug it into any backend and it's just going to work because it is generic. Okay, I'll keep working with it. So you have this type checkout. What else? What else do you have as an operation? Uh, well, for a shopping cart, you have a type add item. I really have to say add item? Maybe not. Type add. And you add what? Well, you add an item. Okay. Okay. Then what? Well, that item is going to be your input. What is it going to output? It's going to output, if successful, it's going to output a updated. Ah, going to output a non-empty cart. Hmm. Okay. Well, what does that mean for a checkout? Our checkout was taking a non-empty cart. Do I really need to say shopping cart anymore? I don't think so. You just say cart. Oh, that's not right. We'll call this cart a non-empty cart. Okay. And there's going to be a cart ID that it has. So you have a non-empty cart and you have an empty cart. Type empty cart. And I don't know. I guess it's supposed to have a same type of structure. Okay, so you have the empty cart and the non-empty cart. All right. Can you dig that? Maybe. Non-empty cart should so our ad now requires a cart ID that's going to operate on, and this non-empty cart going to require a cart ID. And is there anything else that I'm missing? Item is not defined. So say type item equals. I'm still going with this generic thing, but I have a feeling that this isn't going to work out. And I just need to make everything just arbitrary strings and then parse the string for whatever data type that I would like. Item, boom, equals this item ID that's going to be of type, whatever generic type. Okay. So now what? Oh, this item I said is going to be of some type, generic type. So item ID is probably what I want to call that thing. I'm going to say item ID and then card ID over here. And yeah, I don't like this. For the result, I have a error description of type what? Of error. So now I have something like this, which I mean, I'm going to admit it's not that readable. And I know this would terrorize any like junior developer or anybody that's new to functional programming. But well, there's no buts. This is somewhat cryptic. Um, but in a way, you can say that you could just look at the first half of the actual type without looking at its assignment or definition, for lack of a better term. You just look at the first part of the declaration of the type, and you kind of already know what it's going to what structures are going to be required. So the add function is going to require a item ID, and then because all these functions more than likely will output a result type, you kind of can infer that the last two structures are going to be the result type. Hence, if successful, card ID, if not, an error. To check out if successful, uh, no, that's not true. Card ID is only for the cart for record keeping. Um, when we check out, we the output is a transaction, right? It's not a card ID. So again, this is kind of cryptic. I mean, you can see it, right? It's just kind of cryptic. And I don't know, I'll just continue going with it, and then I'll probably just refactor this out so it looks cleaner. It looks like, I mean, a spec is something you should understand. And the way I'm doing things right now, it's just, it comes off as me just being trying to be clever. So yeah, I don't like it. All right. So F that. Get rid of this stuff until we absolutely need it. A string is useful. And for the for readability, a string is preferable. For maintainability, there's like maybe 1 to 3 lines of code to parse that string to get the structure that we want, or the type that we want. Yeah. So change that. There needs to be a card ID. Type parts ID equals, it's not a record, carts ID of string. Okay. So now we have our cart ID, and then we can update our empty cart record, non-empty cart record with our cart ID, something like that. Yeah. What else, Willis? Same thing with item. Like, you now have this notion of a type item ID equals, and you can say item ID of what? Of string. Okay. So over here, you can say item ID is going to be of type item ID, like that. Okay. What else? What else, Willis? I think that's okay for nope, nope. This transaction. Yeah, you guys need to go too. Come here. Come here. All right, and then boom, 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 boom. Yeah, come here. And this string. Wow. Okay. Now error description. Should that be a string, or could that be a string or an exception thing? I think error description I'm going to leave for right now. The transaction ID can now just be updated to that. And oh, Willis. So now I get rid of this, with the exception of add. You know what? After error description is going to be of, it's going to be of a string. And so, just have things legible. Okay. And that's just, when you look at the spec, it's just a lot cleaner. Don't have to try to prove how clever I am, and I'm the only person that knows how to read this. Like this, I think this is just the way to go. Okay. So we have a add in the checkout. You add an item, and now you have a non-empty la la la. When you do an add, you have a cart that is required. So there's a non-empty cart. That would be append to a non-empty cart, and then type add would be a I don't know if add would really be the right word, but that would take a empty cart item. The result is a non-empty cart. So why did I do this? I don't know. I might revert what I just did, but I think that there should be one operation, right? Or at least there's a add to empty cart or add to non-empty cart. Or what's another name when you want to, well, I guess it could be initialize. I don't know. But this whole thing, the reason why I have empty cart, non-empty cart is this whole notion of encouraging illegal states being unrepresentable. So hence when you check out, you can only check out with a non-empty cart. Okay. And if we go to non-empty cart, then something that we probably should consider is that, bring that back, is that a non-empty cart is going to have it's going to have items in it that are non-empty. It's going to be it's going to be item non-empty. And so that item hasn't been defined. Non-empty is going to be this right here, where you have type non-empty equals, and then you have a head. Hold up, non-empty is going to operate on some generic parameter, or generic type, should I say, and then your head is going to be that generic type, and then your tail is going to be a list of that generic type, something like that. What am I doing wrong? What am I doing wrong? What was it complaining about? Oh, I say equal. What up? That. Okay. So your non-empty cart is going to have a cart ID and items in it that are non-empty. Your empty cart just has a cart ID. Doesn't have anything else. All right. So you want to add to a empty cart. You want to append to a non-empty cart. All right. I'll roll with that for right now. Your checkout is going to be a what? A non-empty cart. And your result is going to be, if successful, a transaction. A transaction or a checked out? Transaction for right now. Okay. So we did add in a pin. Well, what if you want to shopping cart, sometimes you want to remove. So you say, well, maybe we should add a pin, and then down here in between checkout, have a type remove. Okay. And that remove is going to, you have to have a non-empty cart if you're going to remove an item. So you, oh, shoot, come here. You have to have a non-empty cart if you're going to remove an item. And so you have a non-empty cart, and then you have your item that you want to remove. And that's going to be a it's going to either be a non-empty cart or a cart with items, or it's either going to be a non-empty cart or an empty cart. So this is where the choice types come in. Or does it? So there's a, no, hold up. There's a remove. Regardless, if you perform a remove operation, it has to be a non-empty cart. But what is the result? The result could be an empty cart or a non-empty cart. Okay. So this is now where I have a choice type where I can say that type cart state equals, and I don't know. Down here I say empty, which is going to be of a empty cart, and then non-empty of a non-empty cart. Okay. So we have now defined something called a cart state. And so when you remove, the result is going to be a cart state. Okay. Now what? Well, does that cart state apply to when you add or a pin? Yeah, I don't know if I want to change that. Potentially, if I do an add, then I have a cart state. Yeah, I think that works. Okay. Now what? You definitely have a non-empty cart as a result. Remove, you can either have empty or non-empty. Checkout, you can only check out with a non-empty cart. Okay. All right. So there's some other things we have to take into consideration. All right. So when you're adding this, we need to have when we're adding, we need to have some reference to the user that's performing this. So you have this cart state. Remove, you have a non-empty cart. And well, if it's an empty cart, maybe we don't care. Maybe we do. But when we have a non-empty cart, then, well, we need to have come here. We need to have the shopper. Okay. And I didn't say user, I said shopper. Okay. And that shopper is going to be a shopper like that. And so I could do this all day, man. I love specking out stuff. All right. So shopper can be something like that. And then they can have a shopper ID, shopper ID, something like that. Okay. We didn't define shopper ID, so then we have to say type, and then we say shopper ID equals what, Willis? Shopper ID of string. Okay, something like that. Okay, now what? But la la la. That's it for right now. That's it for right now. So we have a non-empty cart that has a shopper, and even the empty cart can have a shopper. Okay, KK, come here. Okay. And so shopper needs to get promoted up here. Okay. And something like that. Okay. All right. So now what will this? Oh, come here. So you have add that takes the cart state in an item. Your cart state is going to be an empty cart or a non-empty cart. Okay. Regardless of the cart being empty, you have your shopper. Non-empty, you have your shopper. And you have your card ID. Uh-oh, come here. And you have your card ID. Okay. Okay. What else? We have add and remove for a shopping cart specification, and you have your checkout. It takes a non-empty cart, and the result is going to be a transaction. Okay, I think that's pretty much the gist of a shopping cart at a high level. I think. Okay, that's a shopping cart. We didn't really flesh out what a transaction is, though. Um, Nor did we flesh out the item. So, this item is probably going to require some more attributes or properties. So, this item needs to have a price, and that'll be a price. And it probably needs to have a name. And we'll give it a name. I don't know. Description. And we'll give it a description. Okay. And so we say that type name equals name of string, and then we can say type price equals price of decimal. Now, do I want to say decimal, or do I want to say unit of measure US dollar? Keep it decimal right now. Okay. What else? Description. Type description equals description of string, like that. You like that? Come here. All right. Over here. Come here. All right. Now what? La. Control Shift B build. Okay, Willis. Type checkout. Takes NonEmpty Cart. Result is a transaction. Transaction over here. Oh, Willis. Hold up. Go back. Bring it back. Transaction structure over here. That's in the form of a record. We'll take a, get ready for this, a non-empty cart. Oh, I love it. Bring it down. Bring it down. Come here. Type transaction. It has a transaction ID, but it also has a part that is non-empty. Oh yeah, baby. Yeah, something like that. Come here, like that. This is what you call getting into flow state. Yeah. Okay. And yeah, I think that's all I need for right now. Because then you can have some functions that you can just run the transaction through. And so yeah, you can do that. You can say like there's going to be a total. Total is going to be a total. You like that? Actually, it's a subtotal. Oh, yeah, like that. And then you have, come here, Willis. You have a subtotal. Yeah, like that. And then you have probably have like tax. Yeah. And you have a tax. Yeah. And then you have a total. Okay. Or we can have taxes and fees, you know. You have a total over here. Yeah. And then we want to have fees. Come here. Do fees have taxes? Like when you go on like Priceline or Expedia, do fees have tax? I think they. I don't know if fees have taxes. They probably do, knowing the government. Yeah, fees. Um, Potentially you have fees. Now, this fees can completely be ignored, but I think it's probably useful to have this in here. The additional, or shoot, yeah, fees. That's going to be a fee list. Tax total. Okay, so it's a fee. Um, Type fee equals fee. I feel like that's going to be a record. And then you're going to have a name. Uh-oh, I already have that one defined. Come here. Yeah. Is it name or description? Let's say description. Or is it both? Fuck. It's probably both. Description. Okay. Fee has a name and a description and amount. And amount's going to be decimal. Yeah, I can say that's decimal. I don't have to say amount. Or do I? Well, I already have a price in here. That price can probably be amount or not. Well, a price is a price. A fee is a fee. I think they're two different things. Okay. All right. What else? Oh, hold up. Amount doesn't necessarily mean okay, so maybe fee is a price in this case because it needs to reflect a dollar amount, and you need to be able to add in the transaction the price and the fees and the taxes and stuff like that. Maybe. Or I can have this notion of amounts. I don't know what this is doing up here. Or I can have this notion of a amount where you say type amount equals amount of decimal, or how does this work? I can say like, is it UOM? UOM? Or is it measure? And then type USD. I'm not sure if that's enough. Do I say that equals decimal? Looks like not. I'll just say type. Oh, type. Oh, shoot. USD. And over here, subtotal hasn't been. Let's go back to fee. Fee is USD. And so then I don't know if I wrap that in something. I forget how this works. I have to look up unit of measure, figure out how this stuff works. And so F sharp unit of measure. Fun or Profit by Scott Bloshin. Okay. And the way they use that is, so I had that part right. And then when they're actually leveraging it, they do that. But what if you just want to define that in your structure? That part's not clear to me. So, for example, well, what does the error say? Expected type, not unit of measure. Um, yeah, I'm not sure how to do this. I could say F sharp, unit of measure, and then say record. And let me see if they actually use this in the record. Okay. I think they have something like this. Okay. Something like that. And so your subtotal hasn't been defined yet. So then I can do a type subtotal equals the subtotal of decimal USD. And I could just follow that with tax in total. Tax tax total total. Okay. And this is it so far. Total tax fees, fee, subtotal, cart. Yeah, I think that's it. For the item, price over here is now decimal that operates on a US dollar. Like that, don't you? All right. And Control Shift B and go back to operations. And yeah, these are the types that have been fleshed out so far. Our ubiquitous language for this notion that we call a shopping cart, right? Shopping cart operations right here. Add, remove, checkout. That's it for right now. Okay. Let me see. OCD says there must be order. Okay. There's order, baby. There's order. All right. Anything else? No. For a shopping cart, I think that's okay. You add cart state, remove from a non-empty cart. When you add something, it has to be a non-empty cart. When you remove something, it's a cart state. It could be empty or non-empty. When you check out, you have to check out a non-empty cart. Oh, okay. And there's other things, right? Do we want to clear a cart, or do you want to just remove it one at a time? Yeah, I'm just going to have to remove one at a time. And that's it. That was fair. Maybe in another video, since I already fleshed out the shopping cart specification library, maybe in the other video, I'll do a browse store and do that specification. I'm content. This is good stuff. Good kata. All right. Yeah, I like it. I'm out. Peace.